Okay guys, today we're going to talk about solving absolute value inequalities. Let's start with a basic absolute value equation. The absolute value of x equals 2. What would this be in words? The distance from x to 0 is 2 units. So how would that look on the number line? All we do is draw the number line. Our starting point is 0, and we would go 2 units in either direction. 2 units here, 2 units here, and we would get 2 or negative 2 as our solution for x. But what about for an inequality? What if we had the absolute value of x is less than 2? How would this change this in words? Well, all you would have to do is see that the distance from x to 0 is less than 2 units. So how would that look on the number line? We would still start from 0, but we're looking for numbers that are less than 2 units from 0. So we know the greatest most points would be 2 and negative 2. And we would have an open circle. But the numbers that are less than 2 units from 0 is anywhere that's in between. For instance, we include the number 1 and negative 1, because 1 and negative 1 are 1 unit from 0, which is less than 2 units. If you look at it, it kind of reminds you of a compound inequality graph for an and. So now what if I had the absolute value of x is greater than 2? What would that mean in words? Well, it's very similar to what we had with the absolute value of x is 2, except the absolute value of x, or the distance from x to 0, is greater than 2 units. Greater than 2 units. So if we looked at that on the number line, we're looking at numbers that are greater than 2 units from 0. So we know where 2 units from 0 is. What numbers are greater than 2 units from 0? Well, it'll be anything from 2 in this direction to 2 in that direction. Kind of reminds you of an or. Now, what if I did greater than or equal to? All you have to do is say greater than or equal to 2 units, which means you are including 2 and negative 2 as well. Now let's do it when we shift the starting position. Remember, this means the distance from x to 5 is 2 units. So on the number line, we would start at 5 and go 2 units in either direction. 7 for right here, and 3 would be our values of x. Now you use the same absolute value equation, but I want to do less than 2. So that means the absolute value, or the distance from x to 5, is less than 2 units. So if we were doing it again on the number line, we would start at 5 and we would look for values that are less than 2 units away from 5. So again, we start 2 units from 5 at 7 and 3, but we're looking at values that are less than that. So if you look at, say, the number 6 and the number 4, are those numbers less than 2 units away from 5? The answer is yes, because they're only 1 unit away. So it's all the numbers that are in between 3 and 7. And what do? If you have a less than or equal to, just fill in those circles. Now, what if you have the absolute value of x minus 5 is greater than 2? You would do the same process as before, except our starting position is at 5, and we're looking at numbers that are greater than 2 units from 5. So we would look at what's 2 units from 5, in this case 3 and 7, and what numbers are bigger or greater than 2 units from 5. So it's 2 units, 3 units, 4 units, all that in between. So say the numbers 8 and 2 are locations that are greater than 2 units from 5. So we would put an open circle at 7 and 3 because it's only greater, and we would go in this direction, like an OR. So now I would like for you to do this example in your notebook. The absolute value of x minus 2 is less than or equal to 4 units. How would you graph this solution? Please pause the video and then you can check your answer. So we know that this means the distance from x to 2 is less than or equal to 4 units. So our starting position would be 2, and we would look for numbers that are 4 units away first, so it would be 6 and negative 2. But we're looking at numbers that are less than or equal to 4 units from 2. So we would do a closed circle because it's equal. We are including negative 2 and 6, and less than is anything in between. Now try this example in your notebook. The absolute value of x plus 3 is greater than or equal to 1. Now remember your absolute value rules. How would you change this absolute value inequality to meet your needs? I want you to try this problem in your notebook, pause the video, and then we'll reveal the answer. Okay guys, remember, when we have x plus 3, we remember that the minus sign means the distance between. So it's really the distance from x to negative 3 is greater than or equal to 1 unit. So on the number line, our starting position would actually be negative 3. So we're looking for those that are greater or equal to 1 unit from negative 3. So of course we're going to start with negative 2 and negative 4 because those are 1 unit away and we are including those. And numbers that are greater than 1 unit from 3 are going in opposing directions like this. I really like to do mnemonic devices, so I want to help you remember what it means when you say less than or equal to, and greater equal to when it comes to absolute value inequalities. If you noticed from before, the less thans looked like and compound inequalities. So I like to say less than to help you remember that that's what it looks like normally. And for greater, it looked like an or compound inequality. So I'd like to say great or to help you remember this basic idea. But remember, when you translate an absolute value inequality or equation, you are looking at distance. And if you're thinking of distance on the number line, it should make sense every time. Let's try the homework problems, and that way you can get some more practice.